Hello everyone. Today we can study another important parameter in radioactivity, that is mean life or average life. So in radioactive decay law we have studied the number of atoms in a radioactive sample disintegrate exponentially with time. But actually we don't know which atom disintegrate first, which atom disintegrate second, and so on. So atoms disintegrating first will have a lifetime 0, and atoms disintegrating last will have infinite lifetime. That is, the lifetime of the samples varies from 0 to infinity. And every atom, the lifetime varies from 0 to infinity. So from the radioactive decay law, we know n is equal to n0 e raised to minus lambda t. N0 is the number of atoms at the beginning, and n is the number of atoms remaining after a time t. So here we can consider that dn be the number of atoms disintegrating between time t and t plus dt. So dn is the number of atoms which get disintegrated between time t and t plus dt. So this dn atoms will have lifetime between t and t plus dt. So since dt, delta t, is very small, we can say that each of these atoms have a lifetime of t. So what will be the total lifetime of dn atoms? That is, total lifetime will be the sum of these. So this is very small, so we are taking the integral dn t. That is, suppose n1 atoms will be having a lifetime t1, n2 atoms will be having a lifetime t2, and so on. So combining all these, what we get, total lifetime will be integral dn into t. So the mean life, it is represented by the letter t bar. It will be equal to total lifetime. What is the total lifetime? Integral t dn. And we have said the lifetime varies from 0 to infinity. That is, atoms disintegrating first will have 0 lifetime, and atoms disintegrating last will have infinite lifetime. Divided by total number of atoms. What is the total number of atoms? That is the number of atoms present initially in the sample. That is n0. So next we have to find dn. So what is dn? N you know, n is equal to n0 e raised to minus lambda t. So dn will be, n0 is a constant, into e raised to minus lambda t into minus lambda dt. So this minus 10 we will not be taking. It just shows the number of atoms are decreasing with time. So we can write it as lambda n0 e raised to minus lambda t dt. And we are finding the expression for mean life. So it will not be negative also. So substituting in t bar is the mean life. That is equal to integral 0 to infinity t dn. Dn is lambda n0 e raised to minus lambda t dt divided by n0. So n0 get cancelled. So what we get? T bar is equal to integral 0 to infinity lambda t e raised to minus lambda t dt. So we have to integrate this equation. So now we have to apply integration to this combination function. So here we have to apply integration by parts. So integration by parts, the formula is first function into, here we are taking the first function as t and second function as e raised to minus lambda t. So integration by parts is first function into integral of the second minus integral of derivative of the first into integral of the second. That is, t bar will be lambda into first function. First function is t. First into integral of the second. That is e raised to minus lambda t divided by minus lambda within the limits 0 to infinity minus integral of, again the limit 0 to infinity, derivative of the first, derivative of t is 1 into integral of the second, that is again e raised to minus lambda t by minus lambda, that is lambda into, if you are applying the limits to this part, if you are applying infinity, that is infinity into e raised to minus infinity will come here. So e raised to minus infinity, it is 0. That is 1 by e raised to infinity is equal to 1 by infinity, that is equal to 0. So applying first limit, this term gets 0. And applying the second limit 0 also, this term will be 0 since t is 0. That is 0 minus 0. It is this term gets cancelled. And here 2 minus signs, so it becomes plus 1 by lambda into, applying applying integration, we get e raised to minus lambda t integral 0 to infinity. So applying this, what we get? T bar is equal to, one lambda is there, lambda into 1 by lambda integral 0 to infinity e raised to minus lambda t. This lambda and lambda gets cancelled. So applying integration, we get e raised to minus lambda t by minus lambda within the limits 0 to infinity. That is minus 1 by lambda into e raised to minus infinity. Again we know it is 0 minus e raised to 0, that is 1. So the final equation will be minus and minus gets cancelled. It is equal to 1 by lambda. That is mean life or average life of a radioactive sample is equal to, it is the reciprocal of decay constant. And the expression for half-life period, T half is equal to 0.6931 by lambda. So this can be written as 0.6931 into 1 by lambda, and 1 by lambda is T bar. So this is the relation connecting T half and T bar, that is T half will be 0.6931 T half. That is T half is equal to 0.6931 T bar, or T bar, average life or mean life will be T half by 0.6931. So 1 by 0.6931 is 1.443 T half. So T average life or mean life will be greater than half-life period by the amount 1.443 T half. So mean life of a radioactive sample is 1.443 times greater than T half. And also remember T bar is equal to 1 by lambda. That is, it is the reciprocal of decay constant. Okay, thank you.